Hi, so we're going to start, we're going to talk about trig functions of special angles. I'm going to derive them for you. I'm also going to show you how to create a table of the important values very quickly without, using a lot of brain cell energy. And I'm also going to show you a quick video on how to do what I like to call math gang signs. It's using your fingers to find the exact values of these special angles, okay? So let's begin. First of all, we start with a unit circle where the radius is 1, and I inscribe an equilateral triangle. And I do that by drawing a radius to a point on the circle such that this angle here is 60. And since this is also a radius, these two have to be congruent. Okay, and then I just connect these two with a chord. Now, since these two are congruent, we go back to geometry, which says that angles opposite congruent sides are congruent. So then these two angles have to be congruent. Well, if this is 60 and all three angles have to add up to 180, then these two have to be 60. So boom, now I have this equilateral triangle. Now, what I'm going to do with this equilateral triangle is I'm going to bisect one of the angles and draw the height, aka the altitude. And since it's an equilateral triangle, it has to bisect this angle at the top, that's 60, and now I'm going to replace that with 30. Okay, 30 on either side. And also, since this whole side was 1, since it's equilateral, it ends up bisecting this side, so now in these two triangles, those are both a half. Now the question is, what is the length of this side? Well, I'm going to use this thing called the Pythagorean theorem. You could use that for right triangles. I have two right triangles here. C squared is always the hypotenuse, so we have the hypotenuse squared is equal to leg 1 squared plus leg 2 squared. Okay, so I'm solving for one of the legs. So I plug and chug. If I square 1/2, I get 1/4. I square 1, I get 1. And then I subtract the 1/4 from both sides. When I subtract the 1/4 from both sides, I end up with b squared equaling 3/4. And then I take the square root of the top and the bottom, and I end up with, it's kind of hard to see here, b is equal to radical 3 over 2. Okay, the 2's cut off here from my screen. Sorry about that. Anyway, you're allowed to leave the radical in the numerator. So now I know that that side is radical 3 over 2. Okay, so now this is the fun part where I show you where all these values come from. So if I want the sine of 30, the sine, remember that sine of an angle is equal to opposite over hypotenuse. And if this is my point of reference, then this side is opposite, this side is hypotenuse. So that's where I get 1/2 over 1, which ends up being 1/2. If I want the cosine of 30, then cosine is adjacent over hypotenuse. So then that's going to be the ratio of radical 3 over 2 divided by 1, which ends up being just radical 3 over 2. And then if I want the tangent of 30, you know that tangent of theta is equal to opposite over adjacent. So then I end up with radical 3 over 2. It's kind of hard to see that this is a 2 here. And then if I keep change flip, meaning that I do 1/2 divided by radical 3 over 2, ends up being 1/2 times 2 over radical 3. The 2's cancel, and I end up with this 1 over radical 3. Now you're not allowed to leave a radical in the denominator, so I'm going to rationalize it and multiply the top and the bottom by radical 3 over radical 3, which ends up giving you radical 3 over 3. All right, let's keep going. Now let's do the 60-degree angle. Okay. So for sine of 60, okay, we have this side is opposite, this side is adjacent, and this side is hypotenuse. So sine of 60 is opposite, right? Sine of theta is equal to opposite over hypotenuse. So I put in the opposite side, radical 3 over 2 over the hypotenuse, which is 1, which gives me radical 3 over 2. Cosine, you know that cosine theta is the ratio of the adjacent side over the hypotenuse. So I put the adjacent side, which is 1/2, over the hypotenuse, which is 1, and that gives me 1/2. And then you know that tangent is equal to opposite over adjacent. So I take the opposite side, put it over the adjacent side, and then I'm going to keep change flip. So I have radical 3 over 2 times, well, hold on. Let me write it out horizontally. Now I'm going to keep change flip, 2's cancel. And that's why I end up with radical 3 over 1, which is the same thing as radical 3. All right. Now, deriving for the 45, 45, 90. All right, so back to the unit circle. So what I do, again, the radius is 1 unit. So I draw a radius that makes an angle 45 degrees with the x-axis. And then I just draw straight down. So that forces this to be a right triangle. Okay. Now, since this is 45 and this is 90, and all angles of a triangle have to add up to 180, that forces this angle to also be 45. So now I have an isosceles right triangle. Okay, because sides opposite congruent angles are congruent. Okay, so here we go. I'm going to use Pythagorean theorem again. Okay, and I call these both x because they're congruent. Okay, I could have easily called them whatever dummy variable I want, a, b, whatever. But anyway, the point is x squared plus x squared gives me 2x squared. And then I divide by 2, and I have x squared is equal to a half. Well, the way to get rid of that square is to square root both sides. And you know you're not allowed to have a radical denominator, so I rationalize it by multiplying top and bottom by radical 2 over radical 2. So I end up with radical 2 over radical 2. Okay, so now I can replace that side measurement with radical 2 over 2, and this one also with radical 2 over 2. I can erase that now. Okay, so let's go and write out the values using our 3 basic trig ratios. So cosine of 45, you know that cosine is adjacent over hypotenuse. I just have to pick one angle, so I'm going to pick this one, and this is adjacent, this is opposite this angle, and this is hypotenuse. So cosine of theta is equal to adjacent over hypotenuse. So I take the adjacent side, put it over the hypotenuse, and I just get radical 2 over 2. If I want sine, you know that sine theta is the ratio of opposite over hypotenuse. So again, I just take the opposite side measurement, the hypotenuse, divide them, and there we go. And then lastly, tangent of theta is equal to opposite over adjacent, and I just take the opposite side, put it over the adjacent side, and anything divided by itself is 1. So that's that. And it doesn't matter, I could have easily used this angle, and if I had used this angle instead, then this side would be opposite, and this side would be adjacent, and you can prove it to yourself. I'm not going to do it here, but you can prove it to yourself that you would end up getting the exact same values. All right, so now I'm going to show you how to get these exact values. You're really better off if you do memorize these, especially if you're taking an exam where there's no calculator allowed. And also, you know, your brain can be a lot faster than a calculator. I know my brain is. So anyway, so my desire to memorize these comes from a place of laziness because I don't want to have to pick up a calculator. Anyway, so you're going to make a table. And we're only going to put 30, 45, and 60 in it. And it has to go in order from least to greatest. Okay, so 30, 45, and 60. And then you're going to have a column here, and it has to go in this order: sine, cosine, then tangent. Okay, so what you can do once you know how to generate this table, and I'm going to give you an easy way to memorize the steps to generate the table, you make a quick table on your test or quiz, and then you use that to answer whatever questions that you have to do. All right. So first thing you want to do is you're going to enter 1, 2, 3 in that first row. And you want to leave space because we're going to be entering fractions in each of these boxes here. Okay, so 1, 2, 3. All right, and then in the second row, you're going to enter 3, 2, 1. 3, 2, 1. All right, so very easy to remember. 1, 2, 3, 3, 2, 1. Okay, next thing you're going to do is you're going to change all of these numbers to radicals. So radical, 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 radical. Now, if you're wondering why I didn't bother putting a radical over the 1, because that's redundant. We know the square root of 1 is 1. But if you want to, you can. But I'm not. Okay? So very easy. 3 steps. 1, 2, 3. 3, 2, 1. Radical, 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 radical. All right. Then you're going to put them all over 2. Over 2, over 2, over 2, over 2, over 2, over 2. Okay? So 4 steps. 1, 2, 3. 3, 2, 1. Change them all to radicals. Put them all over 2. All right. So how you read this table is if I want the sine of 30 degrees, it's this box. If I want the sine of 45 degrees, it's this box. Sine of 60, this box. Cosine 30, this box. Cosine 45, this box. Cosine 60, this box, and so on and so forth. Okay, so now you're probably wondering, well, what do I do if I want to get tangent? Well, the reason I put the table in this order is because tangent of theta is equivalent to sine of theta over cosine of theta. And if you notice, sine and cosine are on top of each other right here. So if I want the tangent of 30, I just take 1/2 and I divide it by radical 3 over 2, which ends up being 1/2 times 2 over radical 3. The 2's cancel. I get 1 over radical 3. But you're not allowed to leave that radical in the denominator, so you rationalize it. And you get radical 3 over 3. And eventually over time, you'll end up memorizing the tangent of 30 is radical 3 over 3. Okay, make that look more like a 3. And then if I want tangent of 45, I do sine of 45 over cosine of 45, and anything over itself is 1. And then for tangent of 60, I take sine of 60, divide that by cosine of 60. So if I have radical 3 over 2 divided by 1/2, that's radical 3 over 2 times 2 over 1. 2's cancel, I get radical 3. And like I said, you'll eventually memorize that the tangent of 60 is radical 3. And one way that I memorized it is that I would ask myself, who's bigger, 30 degrees or 60 degrees? 60. Who's bigger, radical 3 over 3 or radical 3? Radical 3. So big goes with big. Radical 3 goes with 60. Radical 3 over 3. Little goes with little, 30. And tangent 45 is easy. That's just 1. Okay. Other things you might notice is that the sine of 30 gives you the exact same value as the cosine of 60. Okay. They both have the same value of sine and cosine for 45. They're both radical 2 over 2. And the cosine of 30 gives you the same value as the sine of 60. Okay. And that'll come to light why later. All right, moving on. Memorizing the quadrantials. So remember that you also have the unit circle. So you can use the unit circle to find the sine of 90, cosine 90, same for tangent for 0, 90, 180, 270, 360, because those are the ones that fall on these parts of the unit circle. And remember that x is always equal to cosine theta, the x coordinate, and the y coordinate is equal to sine theta on the unit circle. And that tangent of theta is always equal to y over the x. So that's something that you could always still do. So I'm just presenting more options. So here I have these hands, and it doesn't matter which way you face your hand, if it's facing away from you or facing you. But you have your quadrantial angles, the ones that land on the x and the y axis. So we go 0, 90, 180, 270, 360 on both. All right. So this is just something you could do to memorize. This will make a little bit more sense when we graph sine and cosine curves, but I'm basically using a sine curve and what one cycle of a cosine curve makes. But notice that sine starts at 0, ends at 0 when you cycle from 0 to 360. Cosine starts at 1, ends at 1 when you cycle from 0 to 360. And it alternates between 1 and -1. So we go 0, 1, 0, -1, 0. So if I want the sine of 180, that's my middle finger, and it goes 0, 1, 0. So I know that the sine of 180 is 0. If I want sine of 270, I know that's my fourth finger, and it goes 0, 1, 0, -1. Okay, same thing for cosine. It goes 1, 0, -1, 0, 1. So cosine starts at 1, ends at 1, alternates with the zeros and the positive and the negative ones. So if I want the cosine of 90, I go 1, 0, and I know the cosine of 90 is 0. Okay, if I want the cosine of 360, that's going to be my last finger, and I go 1, 0, -1, 0, 1. So I know cosine of 360 is 1. All right, I got to do these in like a minute. So I have find the exact values of the following: tangent 30, cosine 45. So you're going to use your table, and over time, you'll start to memorize them. All right, tangent 30 is radical 3 over 3, and cosine of 45 is radical 2 over 2. You know how to multiply. You multiply straight across. You can multiply radicals together. That's radical 6 over 6. Don't reduce, okay, because one of them is under the radical, the other one isn't. Sine 45 squared and cosine 180. Well, and also this is the same thing. If it's written like this, it means the same thing, okay? So I'm just going to square radical 2 over 2, multiply by the cosine of 180, which is -1. Square the top and bottom. We get 2/4 times -1, -1/2. Okay, sine 60 times cosine 30 plus tangent 60. We're just going to follow the order of operations. Okay, multiply straight across. Okay, we get 3/4. And then if I want to mush those together, I have to get a common denominator. So I multiply this one by 4/4 and then add them. Done. That's it. And if it's radians, whatever, you can convert radians to